Students begin 8th grade by building on prior understandings of geometric figures to explore rigid transformations and congruence. They start by working with translations, which slide each point of a figure the same distance in the same direction. Then they investigate reflections. A reflection flips a figure across a line to form a mirror image. Students compare a figure and its image to find that corresponding points are the same distance from the line of reflection. Next, they explore rotations. A rotation turns a figure around a point called the center of rotation, and students see that each point on the figure turns by the same angle measure in the same direction. Rotations, reflections, and translations are all examples of rigid transformations. Students observe that, after a rigid transformation, a figure and its image are the same shape and size, and they verify these observations by measuring. They see that corresponding sides have the same length, and corresponding angles have the same measure, and any parallel sides remain parallel. Students use what they know about the coordinate plane to further investigate rigid transformations. By looking for patterns, they see that a horizontal translation affects only the x-coordinates. When moving right, they add the number of units moved, and when moving left, they subtract the number of units. On the other hand, a vertical translation affects only the y-coordinates. When moving up, students add the number of units moved, and when moving down, they subtract the number of units. Students also explore how reflections affect coordinates. When a figure is reflected across the x-axis, the x-coordinates stay the same, but the y-coordinates change to their opposites. Likewise, when a figure is reflected across the y-axis, the y-coordinates stay the same, but the x-coordinates change to their opposites. What about rotations? Well, for a 180-degree rotation around the origin, students see that both the x and y coordinates of the image are the opposites of those from the original figure. The patterns for 90-degree rotations are a bit more complicated. For a 90-degree clockwise rotation around the origin, the x-coordinates of the image are the original y-coordinates, and the y-coordinates of the image are the opposites of the original x-coordinates. Students can find a pattern for a counterclockwise rotation the same way. After working with single rigid transformations, students move to performing several transformations in a row to explore sequences of transformations. Working with sequences of transformations, they see that the order in which the transformations are performed can affect the location of the image. For example, a 90-degree rotation around the origin followed by a translation results in a different image than the same translation followed by the same rotation. Students move from understanding sequences of transformations to using them to demonstrate congruence between figures. They learn that two figures are congruent if they have exactly the same shape and size. And they've already learned that rigid transformations preserve shape and size. So, they can show that two figures are congruent by showing that one can be mapped onto the other by a sequence of rigid transformations. Throughout this unit, it's important to focus on students' conceptual understanding of rigid transformations and congruence, as these topics not only set the stage for upcoming topics, like dilations and similarity, but also lay the foundation for much of students' future learning.